Number 3. So if x is a uniform random variable on the interval 0 to 100th, we want to find the probability density function. Okay, so keyword here is uniform random variable. So we know that it has to turn on and then off. So it turns on and then turns off. And we want to make sure that we have the right height here. So what's the width for this? This width is 0.01 minus 0, so 100th. And so we want the total area of this to be 1. So to do that, our height has to be the reciprocal, which is going to be 100. So that shifts it twice and you get 100. Okay, so that's the shape we want. So the formula that's going to give us that is it's going to be 100 when x is between 0 and 0.01, and it's going to be 0 otherwise. Okay, so that means when x is less than 0 or when x is greater than 0.01. All right, so that is the PDF. All right, now since we have a uniform random variable, and we know it's a continuous uniform random variable, the next question is asking what is the expected value. Okay, so you can take this and you could plug it in here, right? Take each observation times the chance of seeing it, sum them all up. But because this is a uniform random variable, there's a formula for it. You average the start and end point and divide by 2. So a plus b divided by 2. So 0 plus 0.01 divided by 2 gives you 0.005 for your expected value or mean. Similarly, what's the variance? Okay, again, you have this function, so you could look at the distance of each observation from the mean, square it, times the chance of seeing it, and then sum all of them up. But because this is a uniform random variable, there's a formula that is equivalent to this, which is b minus a squared over 12. So we have 0.01 minus 0 quantity squared over 12, so that is 0.0001 over 12, which is 8.3 infinite times 10 to the minus 6. Okay, just to show you, so we have 0.01 squared and divided by 12, and that's 8.3 times 10 to the minus 6. That's a pretty small number. Okay, and next, standard deviation. So you find the variance somehow, right, and then take the square root to get the standard deviation. Okay, so we have this formula, so it's the square root of b minus a squared over 12. So square root of this result gives us 0.002887. Okay, rounded to 4 digits. Okay. And now last part. So want the probability that x is greater than or equal to 0.005. All right, now you might have a sense about what this value is, and if you think about it for a quick second, so you have 0.01. This is a probability distribution. This value is in half, and you know this is a rectangle, so it's going to be symmetric. So you're probably thinking that's a half, but we should check this. But if it would make sense if it's a half. Okay. So this is the area we want to find. So we have a lower bound, 0.0005. We're finding the sum of all possible, the chance of seeing anything above that value. So give me that. Okay. Our distribution shuts off at 0.01. So we divide this into two pieces. So in this zone, it's 100 when it's on, and then outside of it, it's going to be off. So we're integrating 0, so this one's going to end up being 0. So this is the only one we need to worry about. Okay, so the antiderivative for this one is 100x, and then we plug in from 0.005, 0.00 to 0.1. So we get 100 times 0.01 minus 100 times 0.05, so that's so that is 1 minus 0.5, which is 0.5, which is 1/2. Okay, so that's what we expected before we did all that. You can also analyze this by thinking of it as a box. So you have from 0.005 here. So the width is 0.005, and their height was 100. And it'll give you a half as well. Width times height.